Unit 6 review, starting with standard form. Standard form. There's a couple things we did with standard form. The first is if we have an equation in standard form, we might be asked to find the X-intercept and the Y-intercept. To do that, to find an X-intercept, we plug in 0 for Y. X-intercept, put in 0 for Y. So that's going to give me 3x equals negative 12. If I put in 0 for y, the 6y goes away. 3x equals negative 12. We can solve. Divide both sides by 3. And we get our x-intercept of negative 4. X-intercept is negative 4. So we go to negative 4 on the x-axis, and we put a point. We know that that is one of the points on my line. We do the same thing to find the y-intercept, except we put in 0 for the x. If I put in 0 for x, I get negative 6y equals negative 12. Divide both sides by negative 6. And we have a y-intercept of 2. My y-intercept is 2. Once we have 2 points is enough to draw a pretty good graph. We draw the straight line that passes through both those points. So x-intercept, put in 0 for y. Y-intercept, put in 0 for x. The other thing we did with standard form was we switched it to slope-intercept form. This one asks us to change to slope-intercept form and then graph. So slope-intercept form says y equals mx plus b. So I need to solve for y. I need to get y by itself. Start by subtracting 6x from both sides. Bring down our minus 2y. Negative 18 minus 6x, those are not like terms. We want to write the x part first. Negative 6x and then the minus 18. Divide both sides by negative 2. Six divided by 2 is 3. Negative divided by negative is positive. So 6x divided by, or negative 6x divided by negative 2 is positive 3x. Negative 18 divided by negative 2. Negative divided by negative, positive. 18 divided by 2 is 9. We are in slope-intercept form. Y equals 3x plus 9. To graph 3x plus 9, we go up to 9 on the y-axis. We always graph the y-intercept first, and then the slope. And our slope is up 3 over 1. Up 3 over 1. We can also go down 3, left 1 to be on that same line. And once we have plenty of points there, we can draw our graph. We also wrote equations of lines, particularly parallel and perpendicular lines. Parallel lines, remember, have the same slope. Parallel lines, same slope. So this one asks us to write an equation of the line parallel to y equals negative 2x plus 4 that passes through the point negative 4, 6. Equation of a parallel line. So parallel line, same slope. This line has a slope of negative 2. So the slope of our new line should also be negative 2. Start with point slope form. Y minus y1 equals slope times x minus x1. Plug in negative 2 for our slope. Negative 4 for x1. And 6 for y1. Distribute. Negative 2 times x negative 2 times 4, and add 6 to both sides. Y equals negative 2x minus 2 is correct. Y equals negative 2x minus 2. Again, parallel lines have the same slope as each other. Perpendicular lines have slopes that are opposite reciprocals. Opposite, meaning one is positive, one is negative. Reciprocals mean we flip the numerator and denominator. So this slope is negative 2 over 1. So my new slope should be opposite. This one's negative, so this one's positive. 2 over 1, I flip it, is now 1 over 2. Other than that, we do it the same way. Point slope form. Y minus y1 equals m times x minus x1. Slope is 1/2. That goes in for m. Negative 4 for x1. 6 for y1. Distribute the 1/2. 1/2 times 4 is 2. And add 6. 2 and 6 make 8. Y equals 1/2 x plus 8. From there, in Unit 6, we moved into systems of equations. First, solving systems of equations by graphing. This is where we graph the two lines, and we find where those two lines cross each other. So y equals 2x plus 3 is in slope-intercept form. Slope-intercept form, we start with the y-intercept, 3. And then we graph our slope. Rise over run. Up 2 over 1. Up 2 over 1. And these we want to graph plenty of points because we're looking for where the two lines cross each other. The other line has a y-intercept of -1. Quick fix. There's a problem with it. An issue with the problem. Change that -1 to a -3. Sorry about that. So it has a y-intercept not of -1, but of -3. And then our slope is -1. -1 over 1. So we're going down 1, right 1. Down 1, right 1. Down 1, right 1. Notice it's going to cross over here somewhere. So we also need to go up 1, left 1. Again, graph plenty of points. Make sure we can see where those two lines cross each other. Make sure you graph your lines in. Don't just plot the points. And then also make sure you state your solution. The solution is the ordered pair where those two cross, which is that point right there. My x value is -2, and the y value is -1. -2, -1 is our solution. It is possible that when we graph the two lines, we wind up with parallel lines where the lines don't cross. In that case, we write that we have no solution. It's also possible that the two lines line up right on top of each other. In that case, we have infinitely many solutions. So solve by graphing. We also learned how to solve by substituting. Solve this system by substitution. y equals 3x minus 5, and 2x plus 3y equals negative 4. Y equals 3x minus 5, 2x plus 3y equals negative 4. So to substitute, we take the equation where it says x equals or y equals, in this case y equals 3x minus 5, and we substitute it in for the y. This is equal to y. So we're going to put it in for the y right there. So I would have 2x plus 3 times y equals negative 4. And instead of y, I'm putting in 3x minus 5. That goes in for my y. Distribute your 3. 3 times 3x is 9x. 3 times negative 5 is minus 15. 2x and 9x make 11x. Add 15. I get 11x equals negative 4 and 15 make 11. And divide both sides by 11. X equals 1. Remember, we need both an x and a y. Once we have x equals 1, we plug 1 in for x. In either equation, I'm going to plug it in the top one, might be easier. Y equals 3 times 1 minus 5. It goes in for the x. 3 times 1 is 3. 3 minus 5 is negative 2. X equals 1, y equals negative 2. And finally, the last type of problem we did was systems of equations by elimination. Solve by elimination. To solve by elimination, we want to add the two equations together so that one of the variables cancels out. So 3 and 2 don't cancel out, and there's nothing easy that I could multiply one of the equations by to make them cancel out. Negative 4 and 2, well, they don't cancel out as is. Negative 4, I want this one to be positive 4. Well, I can make that positive 4 simply by multiplying this equation by 2. So let's multiply that bottom equation by 2. I'm recopying the top equation. 3x minus 4y equals 13. The bottom equation gets multiplied by 2. 2x times 2. 2y times 2. And 18 times 2. Negative 4y plus 4y, those eliminate, they cancel out. 3x plus 4x is 7x. 13 and 36 make 49. Divide both sides by 7. Gives me x equals 7. And substitute 7 in for the x. Either equation works. I'm going with the top one. 3 times 7 minus 4y equals 13. Three times 7 is 21. Subtract 21 from both sides. And divide both sides by negative 4. Y equals 2. X equals 7, y equals 2.